Complete PLC programming course from zero to industrial level, prepared by engineer Adil Saleh. What is SCADA? Supervisory Control System. We reach the highest level of industrial automation systems, SCADA. While a PLC manages localized logic, we are now looking at the system that scales that control across an entire factory. Step by step, we will integrate 4 functional areas: the industrial environment, automation principles, the role of the PLC, and the overarching function of SCADA. This perspective aligns individual machine logic with the logistical requirements of a complete industrial facility. To understand the macro system, we must first establish the exact operational limits of a single programmable logic controller. This schematic shows how a PLC is designed specifically to control a single machine or an isolated, self-contained process. Within this closed loop, the PLC handles physical execution, reading localized sensors and firing physical actuators. This localized control operates at fast millisecond scan times to ensure reliability, but it functions entirely within a silo. The PLC is a dedicated, localized brain, yet it is blind to the operations of the rest of the factory. Coordinating multiple machines requires a higher-level system. The system required to solve this isolation is SCADA, which stands for Supervisory Control and Data Acquisition. Supervisory indicates that the system oversees operations from a top-down perspective, rather than performing the ground-level physical work. Control means the system dictates wide-scale operational parameters and targets for the entire facility. Data acquisition refers to the continuous harvesting of metrics and variables from every corner of the environment. While a PLC controls a single machine, SCADA monitors and controls an entire factory or system. SCADA serves as the macro-level supervisor for the facility, rather than a micro-level executor for a single motor. Look at this architectural floor plan. We are moving from an isolated machine to a factory floor containing dozens of independent systems, each governed by its own PLC. Without a network layer to connect them, these production lines cannot share data or coordinate workflows. SCADA does not generate its own data about the factory. It is entirely reliant on the ground-level sensors wired to the PLCs. The SCADA system collects and pulls this raw data upward from every single PLC on the network. This aggregation transforms hundreds of isolated machine controllers into a single, cohesive digital nervous system. All of that data routes to a central interface, presenting the state of the plant in one dashboard. Production lines are visualized here, allowing supervisors to monitor throughput and efficiency across all sectors. Energy consumption is tracked in the second quadrant, monitoring power usage across the entire plant. Machine status provides instant visibility into whether equipment is running, idle, or faulted. Alarms across the plant are displayed here, allowing for immediate identification of critical failures. The most critical feature is that all 4 of these data streams are displayed in real time. This interface translates millions of raw data points into actionable intelligence for human supervisors. To understand the architecture, we must distinguish how control is actually applied in this hierarchy. SCADA systems do not directly control machines, motors, or valves. Instead, SCADA supervises and coordinates the system by sending commands down to the PLCs. The local PLC is the device that ultimately executes the physical actuation of the machine based on those instructions. This division ensures that machinery is managed by dedicated local logic, while the supervisory layer handles complex strategy. We can visualize this through a split-level hierarchy chart. The bottom layer contains the PLCs, acting as the localized execution brains. The SCADA system occupies the top layer, supervising every node in the factory. This makes SCADA the brain above the PLC brain. You now understand the hierarchy of industrial control, from physical hardware to the digital supervisor. This completes our lesson on SCADA.